today's daily challenge is 1675, minimize deviation in array. Hard question. So you are given an array nums of n positive integers. Okay, you can perform two types of operations on any element on the array, any number of times. So for even element, divided by 2. If the array is 1, 2, 3, 4, then you can do this operation on the last element and the array will be okay. If it's odd, you can multiply by 2. Okay. The deviation of the array is the maximum difference between any two elements in the array. So deviation max diff of two elements so we need to return minimum deviation the array can have after performing some number of operations. Okay, so for example, you can transform the array to 1, 2, 3, 2, then 2, 2, 2, 3, 2. The deviation will be 3 minus 2, which is 1. Got it. 4, 1, 5, 23. You can transform the array after two operations. 4, 2, 5, 5, 3. Then the deviation will be 5 minus 2. Okay. So just thinking out loud, why did it stop here? Why did it stop at the second operation? Well, if we think about how we can make this close to each other, we could find one point. Let's say find one number. And then try to bring all the numbers to that number. Right, so for example, in this case, let's say 1, 4, 5, 23. Let's say we want to bring all the numbers to 5. So let's say we are trying to bring number close to 5. So 4 is already close to 5. So nothing really we can do. 1 we can multiply by 2. And then 2 again to make it 4. For 20, we can divide it by 2. And divide by 2 again to make it 5. And 3, we can multiply by 2 to make it 6. So in the end, we'll have 4, 4, 5, 5, 6. Wait, so deviation should be 6 minus 4, which is 2. There must be some other restriction that I'm missing here then. Then the deviation will be 5 minus 2. Why can't we multiply 2 by 2 again. What am I missing here? So you're given an array nums and n positive numbers. If you do, it's if even. Oh, okay. So you cannot multiply even number by 2. Okay. So that means we couldn't do this. And we couldn't do. Yeah, so we could do this. So basically, we cannot make this to 2. Right? So even though we could make this 3 to 6, we are actually increasing the difference to 4 instead of 3, which is 5 minus 2. Okay, makes sense. So if we decide one number, and we try to bring each number close to that number, then we end up finding the minimum deviation. Then I think the question now becomes, how do we even find that number? We could. Okay. So given 4, 1, 5, 20, and 3. Doesn't matter how many times we apply the operation. So let's say this number actually was 21. Okay. In this case, we cannot actually divide this by 2. So we either have to multiply by 2 or leave it as is. But how do we know in that case? We can try to find odd number that is max. So the one number that we want to converge into should not be greater than this odd max. Because if it is greater, or actually it has to be larger. Well, let me try to think here. So for the odd number, we cannot make odd number go smaller. So whatever the number that we want to make each number become, it has to be greater than the odd max. Greater than or equal to. Because if it is less than odd max, we cannot make this odd any smaller. So there's a less chance to get the minimum deviation. Okay, so that's what I'm thinking here. That means if we have even minimum, the number has to be smaller or equal to that number, because if it's an even number, we can only go down. Yeah, we can only go down to converge into one number. Okay, so if we apply this to, so this was the example I made up. If we apply these two logic to find this single number, to this array, so even minimum is 4. So the number that we converge to has to be smaller than 4. Is that how it's done? Or if it's odd max is 5. It has to be smaller than or greater than 5. Doesn't really fit into this example here. So currently my thought process is, 1, find, well, I think pick is a better word for it. Pick a number to bring all elements. I'll say, so pick a number, try to bring all numbers close to that number, and record deviation. Repeat from step 1 until we run out of numbers to try. So I need to come up with a logic to use for picking a number. I can arbitrarily choose any number. So this can, if we do brute force here, it can be between 1 and 20. So basically min to max, and then try to bring all the numbers to the close one. So for example, in this case, if we try to bring all the numbers to 1, we cannot do it for 5. So 5 is definitely the max. Yeah, we don't want to divide 4 by 2 because it's going away from, or actually, yeah, we do divide 4 by 2 if we choose 1. Yeah. And what about numbers outside of this range? What about 21 or 22? Well, if you think about it, at some point, odd number will become even number. So let's take an example here. So let's say we start from 3. Then we can make it 6, but then we can't really go further because 6 is even number. If we have 5, then it becomes 10. So so odd number times 2 is actually even number. That means if we try to find a number to converge into outside of this range, we are less likely to get to that point, I think. So let's say we want to try out all the possible combination for this. So let's take this as an example. So 1, 4. Let's bring the example back here for this one. Okay. So let's say we multiply, or we are trying 1 through 20. Let's say case 1. We want to bring 4 down to 2. Yeah. And then we want to bring 1 is already 1, so we don't want to bring it down. We can actually also bring down 1 here. So 5, we cannot really bring it down. It's already the minimum we can do. 20 divided by 2 is 10. 10 divided by 2 is 5. So that's 5. 3, I can't really do anything. So in this case, the deviation becomes 5 minus 1 becomes 4. Let's try out case 2. If we try 1, actually not 1. If we want to get to 2, 4 becomes 2. 1 becomes 2 as well. 5, we cannot really do anything. This also becomes 5 and 3. Yeah. So this one gives 5 minus 2, which is 3. What about case 3? 4 is already close to 3. So we're not doing anything. 1 times 2. Okay, 5. Nope. Close to 5, and 3 is already 3. So this also gives us 3. Keep going. Case 4. Well, 4 is already there. 2. Yes. 5 is already there. 5 and 3 is already close. So this also becomes 5 minus 2 equals 3. what if let's say we aim for some large number, let's say 7. In that case, 4 cannot be any larger, so 4 is 4. 1 times 2, 2, but 2 is the maximum. 5 times 2 is 10, but 10 is farther from 7 than 5. So keep it as 5. Same here. And 3 times 2 is 6. So this becomes, we have 6 minus 2, which is 4. Okay, let's say case 8. We're gonna cap at 5, 2, 4, 2. And then 5 times 2 is 10. 10. And then 6 is the max. This becomes 10 minus 2 is 8. So it's obvious that as the number increases, we will get more deviation, because this 4 and 1 will be kept at some even number that has the larger difference as this number grows. So how do we actually know? Okay, so what I'm gonna do is I'm gonna try to code this and see if it's gonna work. Okay, so I said I'm gonna pick a number. So first, I'll need a minimum. I'll mark it as RRR, and it's going to be the minimum of nums and the maximum of the nums. So these are our range. So for you having a for loop in range of L starting from it, and then R plus 1 to get to R as well. Wait, what's the R as well? We are going to try to bring all the numbers. So for nums, we're going to try to bring all the numbers to. So we need a temp array. Okay. We also need target number, which is going to be the number at I. Okay. And then for each number, we are going to try to bring the number close to the target. So how we are gonna do that? I'd keep track of prev as the number, and then while target minus prev is actually greater than target minus current, so if we want to do this, we actually have to take this out. Oh no. So we need to multiply by, let's first think about what we are doing here. So we are doing if n is even or odd, then we can multiply by 2. If it's not, we can divide by 2. And we are going to repeat that until the target number minus the current number is larger than, think about this. So we already have a number that we can bring close to the number. So comparing the difference between current number with the target versus previous number. So previous number can become the first number. Actually, it has to be its own. Right, so we are getting the number as previous number, and if previous num is actually, so how can we do we need to find, so we have previous number, and we can maybe calculate the new number. If its new number has smaller, then the new number now becomes the current number. Let's see. So let's say if we call this current number and say new number is this. So a new number now becomes so we want to keep repeating this operation until we do not meet the requirement. Okay, so when So when I'm gonna call it new number, and actually use it. So always multiply. But if her number is even or odd, that means we need to multiply or divide. Okay, always do the division. If it's odd, do the multiplication. While target minus current num, we actually have to use the math absolute. What's the, how do I find ABS function? Okay, so it's just ABS function. So if there is less difference in current number, in new number than the current number, we can update the current number to be the new number, and then recalculate the new number. So we can repeat this until we get the current number. And then we can append okay. We need to mean deviation. It's going to be the R minus L to begin with, because that's the maximum we can get. When TMP is done, we can, actually this has to be with N. Once this is done, we can find the deviation. By absolute of actually max of TMP minus minimum of TMP. So we're going to repeat this for this range, and then we can simply return mean deviation. I think this can work. Let's try this out. run it. Target equals numzi. Oh, it's not numzi. It's just I. So this is actually the target. Okay. Well, it doesn't seem to work. Okay. So let's run this. Of course it fails. So output is 2, but we're expecting 1. So let's check on the TMP array. So 1.10. Okay, so I'm just gonna make this integer. Same here. Wait, so I think I missed this one. Yeah. I didn't include this previously. So 1111. How does it become 1111? After first iteration. I mean, you cannot multiply 3. Okay, so when it's trying to apply operation on n, when it equals 3. Okay. So when current number is 3, it's not. Okay, I think I'm gonna make this a little bit obvious here. So when it's even number, I'm actually going to divide by 2. So if it's odd, we're gonna multiply by 2. If it's even, we're gonna divide by 2. Let's initialize it. Wait, so what's the matter here? I mean, I'm going to repeat this same thing down here. When I run this, local variable new num. Okay. I'm just gonna initialize it to 0 because it's gonna be overwritten by this if else anyway. Okay. So first case worked. Okay, 1131 makes sense. 1, 2. Wait, how can second example, there's 2. How does it become 2? So you see 3. It's odd number. So I mean, when you see 3, yeah, I'm gonna have to print this out. So let's say print current number. New number. Okay. And I'm gonna repeat this the same over here. And then I want to mark it as the start of the for loop here. So if we run it, so when n is 1, 2, 3, so when n equals 3, current number mod 2 is 1, so new number. Oh, am I not initializing? Oh, okay. So I'm supposed to use the current number here. So new number was basically coming from previous. Yeah. Now it should work. Yes. So for the case of 1, 1, actually get rid of this. Get rid of this. Get rid of this. And rerun it. 1, 1, 3, 1. Yeah, 3 never goes down, which is what I was expecting. 1, 4, 1, 5, 2, and E. So this is basically the case, same as what I got here. So case 1. Okay. Yeah, case 1. 1, 1, 5, 3. 2, 2, 5, 5, 3. 4, 2, 5, 5, 3. 4, 2, 5, 5, 3. Same goes. And then in case of case 8, 4, 2, 10, 10, 6. Yeah. So I think this makes sense. Okay, I'm ready to submit this. I might run into time limit exceeded exception, but let's see. Yeah, this is expected because let's see. Looking at this example, there's 49, 7, no. There must be a really small number and really large number. Because the complexity of this algorithm is, first of all, we are looping through all the differences. So it could completely mean because there can be n's range, or num's I range can be up to 10 to the 9, it's possible that we are looping through 10 to the 9 times. And for each array size. So it'll be of n times 10 to the 9 in the worst case. Okay, so how can we improve this? We might be able to improve the number searching logic, I think, because the basically the way we came up with this range was getting minimum and maximum. Is there? I'm thinking we could use binary search and pick the middle number always until. So that the complexity of that will now be of log n times log of 10 to the 9, which is a lot better than complexity. So how can we choose? So how do we know? Based on this array, let's say 1 to 20, so we chose case 10. Okay, let's say we chose case 10. In that case 10, we're basically bringing caps at 4, 1 cap at 2, and then 5 can become 10. This one as well, and 6. So this becomes 10 minus 2 equals 8. So let's say this was the very first result we got. How do we know? Well, we know that 4 cannot be greater than we can potentially count number of elements that are at the cap, so that they cannot reach that number. For example, this 4 can never be greater than 4. This 2 can never be greater than 2. So maybe what we can do is, once we have this array, so this is one formation of what we can do. We can pick smaller range by choosing 2 and 10. Okay, so this is a lot smaller range. So let's say we are now using this 2 and 10. 2 and 10. So the midpoint will be 6. So we are trying to get to 6 at this point. 4, 2 cannot change. 10 divided by 2 is 5. 10 divided by 2 is 5. 6 divided by 6 is already 6. So that's fine. In this case, it can be 6 minus 2 equals 4. Now we have smaller range. 2 over here and 6 over here. So now the range is 2 to 6. Midpoint will be 4. Then 4, 2, 5, 5, 3. Now it's 5 minus 2 is 3. So now we need to figure out when to stop. So there's 2, there's 5. 2 to 5. Mid 3.5, let's say 3 into the division. Well, 4 is there. 2 cannot change. 5 cannot change. 5 cannot change. 3 is there. 5 minus 2 is 3. So at this point, we choose L and low and high, but it's basically the same range. So when new range is same as the old range, stop searching. Okay, so let's try this algorithm here at this point. So let's say mean deviation is r minus 1. So new range is going to be so new L, old L. I'm gonna call it old L and old R will be same as RR. 하랑아! 좀 이따 나갈 테니까 지금 아빠 이거 하고 있으니까 좀 기다려. So I'm making old L and old R, and then basically I'm going to check as long as the range is not the same, we can keep digging into it. So if we want to do this, we can actually just make the old L and old R to be different to begin with. Okay, so in the end, we're gonna have to assign the old L, old R to become L and R, and then calculate the new L and R to be minimum of TMP and the maximum of TMP. And then we're gonna basically copy this logic here. So TMP, the entire logic, back over here. Okay. And then the target will be the midpoint. So it's gonna be L plus R minus L divided by 2. Okay, so new number, current number, same logic to find. Okay, finding the mean deviation. Cool. And then okay, and in the end, returning mean deviation at the end. Yeah, so let's run this. So it's not. Okay, let's re-enable this logic here, this printing statement. Wait, so why does n start with 4? Oh, because it's the number. Okay. So new number becomes 2. Wait, what's the target? Target 10. Okay. 5 becomes 10. Cool. 20 becomes 10. So in the end, 4, 2, 10, 10, 6. Yeah, 4, 2, 10, 10, 6. Okay. And then target becomes 6. And the temp will be 4, 2, 5, 5, 6. Wait, but why does it stop there? Why does it stop there? So it's gonna get mean of 2, max of 6, which is a different range from previously. So it's gonna get old L and old R becomes old L, old R, L, R. Old L, old L, old R, R. Let's run it. So 2 to 10, 2 to 6. Oh, because one of them is same. Okay, so this is the wrong. It has to be or. So if any one of the range is different from previous, we continue. Awesome. Okay, so I think that will work. Okay, let's submit. So 35. What do we expect to happen with 35? Okay, so it's going to be the range of 3 and 5. Okay. So let's say 3 to 5. It's 3, 5, mid is 3 plus 1, 4. So it's gonna try to bring to 4. So 3 will stay. And 5 will just stay. So deviation is 2. And the new range, oh, so it's not gonna update to the new range. How can we solve this one? It's not finding because it generates the same temporary array. What's needed to make this 3 to be multiplied by 2 to reach 6? Well, we are not considering 6 because we are only searching for these two, between these two. But actually what we need to be aiming for is 6. Yeah. I mean, if like really, if we really want to get this right, I think if we allow to get to 6, we need to multiply by this by 2. Let's say we just add 10 to the new r for fun. Would this work? Might. Yeah, it will never find the same range. Yeah, I think at this point I ran out of all the things I can try out. Okay, at least I got. Let's see, how many test cases do I get right? 56. So yeah, I give up. Let's take a look at the solutions.